So let's talk about something that sounds like it's straight out of science fiction. We're diving into a project called Qubitcoin, which mashes together two of the heaviest subjects out there, cryptocurrency and quantum physics. And it asks a really huge question. What if we could take all the power from crypto mining and use it to solve some of the biggest problems in science? But let's start with a simpler idea. Just imagine for a second. What if the laptop or phone you're on right now could be a tiny piece of a global supercomputer? Not for mining Bitcoin or anything like that, but for actually helping to discover new medicines or design new forms of clean energy. Just keep that thought in your head as we go through this. Because you see, before we can really get what Qubitcoin is trying to do, we have to understand the problem it's trying to solve. And that problem, it starts in the very, very strange world of quantum computing. To really get this, we have to zoom way down to the level of atoms and particles. And down there, the rules of physics just get weird. Particles can literally be in many places at the same time. It's this quantum weirdness that holds the keys to so many breakthroughs. But trying to simulate it on a normal computer is just incredibly, incredibly hard. Here's the core of it. Asking your laptop to truly model quantum physics is like trying to paint a masterpiece using only a crayon. You just can't capture the detail. Quantum simulation, on the other hand, is built from the ground up to speak the native language of atoms. It gets it. So who actually has this incredible power? Well, it's a pretty exclusive club. You've got the tech giants, the big names you'd expect, and a few other hyper-specialized companies. They are the gatekeepers of this new world. And what that means is that maybe the most important computational tool of our time is stuck behind a huge wall. If you're a student or researcher at a small university, or just an innovator with a brilliant idea, getting access is almost impossible. It's expensive, it's restricted, and it's totally controlled. And that is where Qubitcoin comes into the picture. The whole idea is that it's a new kind of key, one designed to unlock that walled garden and give everyone a chance to use this amazing technology. This right here, this is the mission statement, and it's a powerful one. It basically says, look at all this insane amount of energy and computer power being used for crypto mining. What if, instead of just crunching random numbers, we aimed all of that power at solving real-world scientific problems? This slide gets to the very heart of the idea. Bitcoin mining is based on something called proof of work. You're basically solving a useless puzzle just to prove you spent the energy. Qubitcoin's model is what they call proof of useful work. The work itself has value. So instead of just burning electricity for security, you're turning that same electricity into a decentralized supercomputer for science. And this didn't just pop up out of nowhere. It actually has some serious academic roots. The idea was born back in 2022 around researchers from MIT and Vanderbilt. It went public in late 2024, and now there's a whole nonprofit in Texas called Superquantum that helps guide the project. Okay, so that's the big idea, the theory. But how does it actually work, in practice? How could your computer at home actually become a part of all this? Well, it's actually designed to be surprisingly simple. You connect your computer's hardware, usually graphics card, run their miner software, and that's pretty much it. Your machine starts getting little pieces of giant simulation problems from the network, solves them, and in return for that work, you're rewarded with QTC tokens. Now here's a really clever bit of the technical design. It's called Bring Your Own Simulator. This just means the network isn't locked into one type of software, so it can evolve as the tech gets better. But the most important part is that it's designed to be hardware agnostic. This is a huge deal because it helps prevent a takeover by specialized mining hardware, those ASICs that have made Bitcoin mining so centralized in the hands of a few giant companies. So you're mining, you're earning these QTC tokens, but what are they for? What gives them any real value outside of just people trading them back and forth? The answer is all about utility. Think of a QTC token less like a coin and more like an access pass or a compute credit. If you're a scientist and you need to run a massive simulation, you use QTC to pay for that time on the network. The token is the key that unlocks all of that decentralized power. And just like Bitcoin, there's a hard cap, 21 million. That's it. There will never, ever be more QTC tokens than that. This idea of digital scarcity is baked right into its DNA. They also copied another one of Bitcoin's most famous features, the halving. All this means is that every so often, the reward from mining gets cut in half. This makes new tokens harder and harder to create over time, which is designed to make the existing ones more valuable, assuming demand for the network keeps growing.
All right, now we have to talk about the elephant in the room. Anytime you put the words quantum and crypto in the same sentence, you have to ask one massive question about security.
Let's just put it out there. Couldn't a government agency or a huge lab with a real quantum computer just fire it up, outmine everyone else, and completely take over the network? The answer, and this might surprise you, is actually no, at least not for now. And the reason is fascinating. The specific kind of math problems the miners are solving, these tensor network workloads, are things that today's quantum computers are actually not good at. There's no known quantum advantage for these tasks. Ironically, a good old-fashioned GPU is still the best tool for the job, which protects the network from quantum computers. So, when you put all of these pieces together, the useful work, the tokenomics, the security, what's the end game? What's the grand vision here? Their ultimate goal is to become, and this is a really great way to put it, the Linux of quantum simulation. You know, just like Linux gave the world a free open-source alternative to Microsoft Windows, Qubitcoin wants to create an open, community-driven alternative to the closed-off systems of the tech giants. And listen, this isn't from far-off dream. It's happening right now. In fact, today is a massive milestone for the project. It's the day of the MIT demo, where the network is being shown off live to the academic world for the very first time. It's moving from a wild idea to a real working thing. Which really leaves us with one final big question to chew on. Are we looking at the start of a totally new way of doing science? One that's open, that's collaborative, and that's powered not by a few corporations, but by everyone? Is this what the future of science looks like? Now that is something worth thinking about.